Okay, Assalamualaikum dan selamat sejahtera. Okay, so today we proceed our chapter which is rate of reaction. But this time we go into factors affecting the rate of reaction. And this is the second factor that we will learn. So, which is concentration. So, when it's come to concentration, of course, we have concentrated, the words concentrated or diluted. Okay. So, for a good example, you can see air sirap. Okay. Air sirap. Kalau warna merah tu terlalu gelap, so kita kata concentrated. Because terlalu banyak solute yang kita larutkan dalam solvent. And kalau warna merah tu semakin pudar, kita panggil air sirap tu cair, which is diluted. Okay. So, concentration. What is concentration? The concentration of a solute in a solution can be changed. So, this one boleh diubah kepekatan dia. Okay. So, the concentration of the solution can be changed by adding solvent or solute. Okay. So, if we add solute is bahan terlarut zat yang kita larutkan, it becomes high concentration. But if we adding solvent, it's become low concentration. Contoh kita buat air sirap, kita tambah lebih banyak air, so dia akan jadi lebih cair. Kepekatan dia rendah. Kalau kita tambah lebih pati sirap, gula, so dia akan jadi pekat. Okay, now we go to experiment regarding the factor of concentration. Okay, for this one, to investigate the effects of concentration of reactant on the rate of reaction. So, kita nak fokus concentration of reactant on the rate of reaction. So, our problem statement, how does the concentration of reactant affect the rate of reaction? Okay. Then, hypothesis, the higher the concentration of sodium thiosulfate solution, the shorter the time taken for X mark disappear from view. Okay, so our variable we have manipulated, which is concentration of sodium thiosulfate. And then responding, we have X mark, time taken for X mark to disappear, which is time taken. This one concentration. And fixed is a temperature. Or you can say concentration and volume of sulfuric acid. Or you can say the size of conical flask. Or you can say the total volume of mixture. Okay. We have many fixed variables here. So for material, we have 1.0 mol per dm cube sulfuric acid, 0.2 mol per dm cube sodium thiosulfate solution, distilled water, and white piece of paper with X mark at the center. For the apparatus, we use 150 cm cube conical flask, stopwatch. Okay, all rate of reactions experiments must use stopwatch. And then measuring cylinder, which is 10 and 50 cm cube measuring cylinder. Okay, the procedure. Put 45 cm cube of 0.2 mol per dm cube. This one V, this one M. For sodium thiosulfate solution in the conical flask. And then place the conical flask on the X mark on the white paper as shown in figure 7.14. So, kita ada white paper, kita buat X mark. Normally, kita guna filter paper. Kita buat tanda X mark. Okay. Swiftly, pour 5 cm cube, 1.0 mol per dm cube sulfuric acid into the conical flask and at the same time start the stopwatch. Swirl the conical flask gently and place it again on the X mark. Observe the X mark vertically from the mouth of conical flask. This is your eyes. Okay. Stop the stopwatch once the X mark disappeared from view. and record the time taken. So repeat the experiment by using 0.2 mol per dm cube sodium thiosulfate that has been diluted with distilled water as given in table 7.5. The volume of 1.0 mol per dm cube sulfuric acid is fixed at 5 cm cube. Maksudnya kita cairkan. So masa kita buat eksperimen ni, so kita ada X mark right on a piece of paper, and then when we add sulfuric acid, so what happen? Dia akan berlaku pembentukan precipitate, okay, atau pembentukan insoluble substance yang akan block kita punya pandangan terhadap X mark. So dia akan jadi macam ni. So what happen during the reaction? Sodium thiosulfate react with sulfuric acid, which produce sodium sulfate, which is salt, sulfur dioxide, which is a gas, sulfur, this one is a solid, and water is a liquid. Okay, so sodium sulfate is a soluble salt. So actually it is colorless solution. So what makes the X mark disappear from view is normally a sulfur, because sulfur is a solid. Sulfur ni, actually sulfur is yellow in color. So masa mula-mula you all buat eksperimen, masa X mark tu hilang tu, you all akan nampak macam putih-putih susu. Tapi kalau biarkan lama-lama, dia jadi putih kuning. Dan lama-lama dia boleh jadi kuning, because the sulfur is actually yellow in color. Okay, sulfur is yellow in color. Sulfur biasanya kita kenal dengan nama belerang. Siapa yang pernah tengok belerang tahulah. Okay. Okay, this one is a table. So in this table, the volume of sodium thiosulfate for every set ni, we decrease 5 cm cube, but then we top up with distilled water to make it 45. Okay, so this one the table given. So as you can see, the volume of sulfuric acid is fixed. Okay, but volume of distilled water increase as the decrease in volume of sodium thiosulfate. And this one is data that I give it to you, so we can plot a graph. Okay, so this one is a time taken for X mark to disappear from view in second. Okay. Okay, next, interpreting data. The concentration of dilute sodium thiosulfate solution is calculated using formula M1V1 equals to M2V2. This one is for dilution. Okay, so use the given formula and the data collect to calculate the concentration of dilute sodium thiosulfate solution. In the experiment, the rate of reaction is inversely proportional to the time taken for the X mark to disappear from view. Thus, rate of reaction is 1 over time. Okay, you must remember that the rate of reaction equals to 1 over time. Okay, so next, concentration of dilute sodium thiosulfate. This one, you use M1V1 equals to M2V2. So example for set 2, M1V1 equals to M2V2. So our M1 0.2, V1 is 40. Okay, and then M2 you need to calculate, and V2 is 45. So if you calculate this one, you may find M2 0.2 times 40 divided by 45. So 0.1777 or 0.18. So use this formula to calculate all the diluted sodium thiosulfate. Okay. Then from the time you get from the first table, find the rate of reaction, which is 1 over time. For set 1, you can see 18 seconds. So 18 seconds. So for set 1 is 1 over 18 seconds. So 1 over 18 seconds. So we get 0.0555. Also get into 0.056. Okay, 3 decimal. Okay, then follow the method to find all the 1 over time. Okay, next, plot the graph. Okay, for concentration, normally we have 2 graphs for this experiment between sodium thiosulfate and sulfuric acid. So the first one is concentrations against time. Okay, so from this graph, we can conclude that if the concentration is higher, the time taken is shorter. But when the concentration is lower, time taken is longer. Okay, then we change to the graph 1 over times against concentration. 1 over time is a rate of reaction. Okay, from this graph, you can get rate of reaction for every concentration of sodium thiosulfate. Okay, so example, if you want to get the rate for 0.12 mole per dm cube sodium thiosulfate, just draw a line and then find the y value here. Okay, because 1 over time is a rate of reaction. Okay, why does the solution in conical flask turns cloudy? So, because the formation of insoluble solid in water. Okay, name the substance that causes the solution to turn cloudy. Sulfur. Okay, sulfur. That's make the solution turns cloudy and make it X mark disappear from view. The X mark disappeared from view when the solution in conical flask reach a certain level of cloudiness. What are the steps required in this experiment so that the same level of cloudiness is achieved in all the 5 experiments? Okay, the first one, the total volume of the solution is maintained. Okay, and then the height of the solution in the conical flask is maintained. This one kalau you all guna beaker size besar dengan kecil. So, bila you all guna beaker size besar, ketinggian larutan tu akan jadi lebih rendah sebab dia luas permukaan bawah tapak dia tu lebih besar. But if you use smaller conical flask, so apa yang kita dapat? Larutan tu akan jadi lebih tinggi berbanding kalau kita guna lebih besar. So, ini akan mempengaruhi penglihatan kita terhadap X mark. Okay, that's why the total volume of solution is also maintained. Kita tak nak nanti banyak, air jadi tinggi. Okay, kalau dia sikit, rendah. Nanti bila rendah, X mark tu lagi lambat hilang. And then the third one, use a white paper with the same X mark. Kalau boleh, X tu X yang sama. Takut satu tu korang buat X tu size dia halus. And then cepatlah nampak disappear from view. But another set pula, you all buat bold punya X. So jadi terang, gelap gitu. So lambatlah hilang X mark tu. That's why in this experiment, normally the same person will observe the X mark disappear. Sebab yang ada orang dia cepat dia rabun, dia cepat hilang X mark tu. Ada yang tak rabun. Okay. So what are the changes being measured in the experiment to determine the rate of reaction? So it's the time taken for the fixed mass of sulfur to be formed. Kita anggapkan X mark tu hilang bersamaan dengan same quantity of sulfur yang terbentuk. Okay, next we go to collision theory. So I hope you have learned collision theory for the first factor, which is size of reactant. So according to the collision theory, reactant particle must collide, dia mesti berlanggar with one another in order to reaction to occur. So the rate of reaction depends on the frequency of effective collision. What is effective collision? Effective collision, dia mesti memenuhi dua syarat, which is energy daripada pelanggaran tu equal or more than the activation energy, and second one is collide in the correct orientation. Setiap pelanggaran produce energy, and energy must be equal or more than activation energy. So activation energy is the minimum energy so as to break bond in the reactant particle to form new bond in the product. So kita kena atasi activation energy. Energy daripada pelanggaran tu mesti sama atau lebih besar. Okay. Reactant particle must be in specific orientation to result effective collision. So macam ni kita ada A berlanggar dengan B. Dan masa pelanggaran tu dia melekat and then dia terpisah menjadi dua substance yang berbeza. Dia jadi C. This one is a effective collision. Tapi kalau kita tengok figure 7.2 tu, okay, we have A and B, tapi dia berlanggar tidak in correct orientation. So, dia masih jadi A dan B semula. So, dia hanya berlanggar. Tapi, dia tak dapat capai dia punya effective collision. Dia hanya collision, not effective collision. So, the higher the frequency of effective collision, the higher the rate of reaction. Rate of reaction depends on frequency of effective collision. Kalau lower frequency of effective collision, the lower the rate of reaction. Okay. So, effects of concentration on the rate of reaction. So, this one at low concentration and at high concentration. So, you all boleh tengok, pada low concentration, the number of particle per unit volume is lower compared to the high concentration where the number of particle per unit volume is higher. So, bila banyak number of particle per unit volume, chances untuk berlanggar dan chances untuk berlanggar dengan memenuhi syarat energi itu sama atau lebih besar daripada activation energy, dan juga pelanggaran itu at correct orientation akan menjadi lebih tinggi. So, when the concentration of reactant particle increase, the number of particle per unit volume increase. So, frequency of collision between particle increase. Bila frekuensi pelanggaran tu bertambah, so dia akan meningkatkan frequency of effective collision between particle increase. So, rate of reaction increase. But here, bila jawab exam, particle tu must be specific. Okay, example. Okay, example here. Diagram 5 show two set experiment to study factor affecting rate of reaction between hydrochloric acid and calcium carbonate. Okay, now compare A and B for set A and B. Both use excess calcium carbonate chips. So what is the difference? Both use same volume. But then the difference here. Set B use 0.5 mol per dm cube hydrochloric acid. Set A use 0.25 mol per dm cube hydrochloric acid. Then after 3 minutes, we can collect the gas for set A 60 cm cube, for set B 120 cm cube. Okay, so write chemical equation for the reaction in this experiment. So hydrochloric acid react with calcium carbonate. Acid react with metal carbonate. Will produce salt, carbon dioxide and water. So the gas that we collect is carbon dioxide gas. Okay, next, sketch graph of volume carbon dioxide gas against time for both experiment. We have set A and set B. Okay, so to sketch graph, make sure x-axis, y-axis are labeled, and you need the label for y, volume of carbon dioxide gas, unit cm cube, x is time, unit minute. Then we sketch, make it 60, 120 volume of gas at 3 minutes. Okay. From this graph, it shows that the rate of reaction set B is higher. Why set B is higher? Because the gradient of the graph is steeper. Okay, gradient of the graph steeper. Okay, compare the rate of reaction for both experiment and explain your answer with reference to the collision theory. Bila ayat ni sini, you all mesti explain using collision theory. So, soalan dia tanya, first dia nak compare dulu. Compare the rate. And then explain your answer based on collision theory. So, the first point is compare. The rate of reaction for experiment B is higher than experiment A. Or we can say rate of reaction for set B is higher than set A. Next, why? So the point number 2, you must state the factor. So our factor is concentration. Concentration of hydrochloric acid in experiment B is higher than experiment A. Okay? So, why? What is effect of concentration? So we go to point number 3. The number of particle or the number of hydrogen ion per unit volume in experiment B is higher than experiment A. Because the concentration hydrochloric acid is higher, so that means the number of hydrogen ion per unit volume in experiment B is higher. Then, frequency of collision between hydrogen ion and calcium carbonate in experiment B is higher than experiment A. So, frequency of collision oleh kerana dia acid, so hydrogen ion yang akan react dengan calcium carbonate. Calcium carbonate kita tak sebut ion sebab calcium carbonate tu insoluble salt. Kita just mention calcium carbonate sahaja. Okay, next, point number 5. Frequency of effective collision between particles in experiment B is higher than experiment A. Itu yang menjelaskan kenapa rate of reaction untuk B tu lebih tinggi sebab frequency of effective collision between particle dia in B is higher. Okay, so dalam penjelasan kita dah sebut sekali hydrogen ion and calcium carbonate. It's okay. Bawah ni tak payah repeat lagi. You all boleh just tulis between particle. Kalau you all nak tulis lagi pun boleh. So, Itu sahaja untuk effects of concentration on the rate of reaction. So any questions you may ask your chemistry teacher. Okay, with that, thank you.